Good morning, everyone. My name is Jamal Alabid. We're going to present this paper today to you. Unfortunately, not really physically there, but uh, my co-author is Dr. Taki and Dr. Benta, and we all coming from Leicester School of Architecture, De Montfort University. The presentation is all about simulation of traditional and contemporary housing in Ghadames, in Libya. Um, the outline of the presentation is going to show the case study, a bit of research, problems, aims and objectives, and the methodology that we have adopted and used for this research, findings and outcomes, and finally the research value. Um, the um, the studied area is in Libya, in North Africa, in the middle of North Africa, just between Tunisia, Algeria, and Egypt. This city called Ghadames is some people call it town and city, but it's located in the Sahara Desert, just where the Sahara Desert started. And this is just a bit of features about the old and new settlements. As you can see here is this the town where it is. And these are the new settlements, that's overview. And those just some alleyways and overview picture of the old town and some features of the old town. The research problem starts looking at the energy consumption, where you can see the domestic sectors consuming apparently over half of other sectors. So that's where we looked at the social or the residential buildings rather than other sectors. And while we're looking at cooling, not heating, as you can see in summer, starting from April to August almost, the peak the peak loads here is for cooling rather than heating. So that's the reason why we looked at cooling. The other thing is the urban issues, where the problem starts, to be honest, is the radical transformation of the urban structure between the old town and the new town. As you can see, the very compact urban structure, and that's where the new town is quite open plan, spiral urban design. The other issue is the design issues, where you can look at the lack of solar shadings. There's no shadings here. All the windows are shut down during the day. That means very minimum use of daylighting. Air conditioning also there everywhere, but almost every single room using air conditioning. Even if you can just look at that picture where the blinds are shut during the day, that means people trying to sort out these environmental issues through what they have got. The environmental issue of the sandstorms, that's very common in summer, where people they can't find any solution for that. That's where the solution comes within not some single unit. That's where you have to look at the whole urban structure and the social aspect as well. That's where you can see the old town, the people respecting all these social cultural aspects. Women using the roofs to move around the town, using a kind of bats. And then here they found themselves just outdoors, mixed with other people. The objective is we started looking at identifying some or what's the most common architectural and climatic design strategies that may feed to the future design. Also evaluating existing buildings in terms of energy and thermal performance, of course, the old and new settlements. Also, we looked at subjective surveys, looking at the thermal perception of people, how they feel, and general satisfaction within the old and new settlements that already existed. The methodology we adopted is we carried interviews, a questionnaire, also desk studies that would help as well. Observation, personal observation, case study that where we adopted the typical traditional and modern houses. We carried a range of energy plus simulation to assess or to evaluate the existing modelings, and then that's where we look in to set kind of guidelines for climatic design. This is just where the case study is, the traditional settlements and the alleyways, they call it, and public squares. This is also shaded common of the community spaces where people usually go out and during the day and gather for social activities. This is where the microclimate, the research started with the descriptive and environmental analysis in order to see what can be done for the simulation. That's why we looked at how these structures working, looking at the microclimate, the role of the microclimate overall. The water also plays a significant role, humidifying, just not supplying the water for domestic use. It is also contribute to the thermal conditions, indoor thermal conditions of these settlements. The window design is another issue where you can see traditional buildings, they rely on roof openings mainly, even if it is sided, but that will be fully shaded in light wells. And that's applied for the housing, and also on the street level, you can see here the openings always from the roof, not from sided windows. The protection of the town as a whole, you see the farms and that surrounding the urban structure. That's where they try to sort or to solve the environmental issues like sandstorms. This is a typical traditional house where people live in on town, a 3-story house, begin with they say public spaces, or public or not private, non-private, semi-private and private, where the kitchen and the people summer shed they call it, and double height living room. That's where people spend most of the time. We looked at issues of daylighting. We tried to look at the house without the people using mirrors here to reflect the lights. That's where we design builder using simulation looked at these openings, how it works without reflectives, and gives this amount of daylight. When we set mirrors and reflectives, it shows different distribution of daylighting. You can see the daylighting, how they dealt with it even in street level, using these mirrors in the homes and using these small light well to lit the streets. The air circulating is another thing we looked at it is, and why this is happening is because of the different exposure to sun creates different air pressure. That's where they cause the air movement. At night is something different, where the temperature at night drastically drops down, sometimes from 45 to 25. If it is like 40, it can be around 20. So that people try to find solutions like fans here to get rid of the warm air, because inside became warmer than outside. So it's vice versa, stack effect ventilation. Materials is also another important aspect. You can see the U value of these thermal mass walls, very thick walls, about 70 to 30, depends on the level you are in. This is a typical traditional house, 2-story house, which is the most common there we adopted as a case study. This is the new materials that people use in Newtown. It's just a concrete cavity block material with cement. This is just the model that we created. It's the same as the picture. And this is the way that people ventilate and cool their houses. Mainly during the day they use air conditioning. At night they be able to open, but not that much, to ventilate the houses. People, they looked at blinds because the lack of solar shadings, as you can see here, especially the public housing. So that's where people, they try to shut even these blinds during the day That's why they use artificial lighting. This is where the simulation shows that this is the traditional house and this is the modern house. Modern house using air conditioning, the temperature is okay. It's around 25, but that you can see the energy consumed per hour square meter compared to the traditional ones where it's completely natural ventilation mode and temperature kept between 30 to 32. And you can see the variation of the day outdoor temperature during the day can be around even 45 or something, drops at night around 28 or even lower. This is just where we assess the thermal perception of people. Most of people, they are okay, they don't want change, or they slightly want the environment to be cooler. We compared also the AMV and BMV modeling, the comfort modeling. We found that the adaptive model works better for traditional housing. This is just a bit of suggestions that we propose, especially for the palm tree fibers, that we found people already using that in traditional town, which now these days found to be very good insulation material, limestones as finishing. All these readily available material can really create big impact on the future of housing. This is just a comparison of the existing housing, traditional and modern housing. So in terms of area, the form, the typology, and you can see the occupancy per square meter, all the window to wall ratio, the construction materials, or the using of the courtyard, where the old housing using covered central courtyard. And the other thing is we already think shown is the total annual energy consumption. You can see that 60% reduction, and that also can be enhanced if we're looking at a new models, taking consideration of the bioclimatic concept or the strategies that have been used in traditional settlements. Of course, the renewables is not really taken into account in both either contemporary housing or the traditional, but that's one of the things that we could look at in the future. The value of the research or the impact of the research, of course, it has an impact on the academia or non-academia fields because it has empirical and theoretical research base. Also, these kind of studies can help creating a guide or platform for guidelines for future housing. Of course, it's important for the designers and end users. The economic-wise aspect, where using readily available material or looking at compact design, you can reduce or look at these issues like transportation, natural environment, reducing the cost of the material. All these, the ecological system also, it can be enhanced looking at these strategies. Of course, we're looking back to the vernacular architecture. That's another aspect we can consider is important for our research. The methodology that we have used also is important and is not just applied to the context we have used. It can be used or applied in other similar contexts. Thank you for listening, and please do email me for your feedback. Would be appreciated if you can do that. And thank you very much for listening.